All right, guys, in number 78, we've got a particle in motion right here, and they give you the velocity function for that particle right there, and then they're giving you information and then also a question about position. So if we're looking to go from velocity to position, this is probably going to be an integration problem, and I believe this is going to be an FTC Part 1 issue right here. So for FTC Part 1, we're going to just kind of adapt this here to a PVA problem. So the definite integral from A to B of, now really this could be any function that you put right here. We're going to put the function which we know something about, the velocity function. And to evaluate that integral, we anti-differentiate whatever this function is. And in this context, the antiderivative of velocity is position. So this will be the position of the function at time B minus the position of the function at time A. And not that it matters here, guys, but remember what you're really finding there is displacement in the object, change in position on that interval. So for us, we're going to set up an integral right here from, let's see, we've got t equals 2 and t equals 4. So those are our limits of integration. Our velocity function was given to us as 4 over t cubed plus 1, doing that integral with respect to t. That'll get us the position of the object at the upper limit of time, that would be 4, minus the position of the object at the beginning time, which is going to be 2. So this is an expression we should be relatively familiar with, and what I want you guys to realize now is this is a three-part equation. There's one big term over here on the left-hand side, and then two terms being subtracted on the right. And usually in a problem like this, they've given you one of the three, and that's what we have right here. The position of the particle is x equals 1 when t is equal to 2. So this s of 2 over here is 1. They've given you enough information to find a second one of those three terms, and that's the integral right here, which I'm going to go to my calculator and evaluate in just a second. And then one of the three things, in this case here, s of 4, that's the unknown that we're trying to solve for. They want us to figure out that value of s of 4. So there's one unknown there, and we should be able to do this. So I do not have my calculator up and running here. So let me go here. Okay, and where are we? We are down here, guys, and let's do a definite integral here. So menu 43 for you guys, calculus and an integral, and this integral was going from 2 up to 4, and the integrand here was going to be a fraction, and I think it was a 4 on the top. Did I have that right? Oh, sure. And then t cubed plus 1 on the bottom here. All right, so 4 over, there we go. All right, I'm just going to do an x. That'll be a little bit faster. So an x cubed, oh shoot, was it plus 1? Yes, it was. All right, so x cubed plus 1, gotcha, and we'll run that whole integral with respect to x, gotcha, and we'll hit enter right here. That's not what I wanted, so let me get the approximate answer as a decimal. All right, and we've got 0.353 if we were going to round that to 3 decimal places here, 0.353. Okay, that's what we've got, and then now, guys, just to solve for s of 4, all we have to do is add a 1 on both sides right there, and we're going to get what should be our answer here. S of 4 is equal to 1.353, and it looks like our answer here is C. I'm a little surprised that this value right here wasn't one of the 4 choices right here. I thought a common mistake would have been that people just did the integral and then forgot to deal with the initial condition at all. But anywho, that's what we have right there, 1.353, so it looks like the answer for number 78 is C.